Interconnect S parameters can be measured with a network analyzer and saved to a file that can then be used as a simulation model in System SI simulations. Here we have a 4-port S parameter model that was measured from a differential pair transmission line on a network analyzer and saved to the file dplayer1.s4p. We would like to use these S parameters as a model in System SI to include the differential pair transmission line in the simulation of our channel. To use the S parameter file as a model in our channel, we first need to select the Add S parameter block from the System SI icon block and add an S parameter block to our canvas. We can then double-click on our new block to open the property form for the block. We'll select the Load S Parameter button in the Properties form, and we can then navigate to the directory where we stored our S parameter file. And then open the S parameter file. A SPICE wrapper is created for the S parameter file, and that SPICE wrapper then points to the S parameter file that we loaded. Notice that the Model Connection Protocol section of our model is incomplete and must be created manually. To create the MCP section of our model, we'll select the Edit MCP Header button in the Property form. In the MCP Header Editor, we see 4 connection ports. This S parameter model was for a differential pair, so we have 4 ports, but we want only 2 connections. So we'll delete the 4 existing connection ports. And we'll create 2 new ports, one called left for the left side of the block, and one called right for the right side of the block. Our 4-port S parameter model has 4 circuit nodes. We'll select our left port and then add node 1 and node 3 to our left connection port. And we'll also include the N-ground circuit node as our ground node. To make the model more intuitive, we'll call the nets on our left connection port in plus and in minus. Next, we'll select our right connection port and add circuit node 2 and circuit node 4 to our right connection port, again including the N-ground circuit node as a ground connection. And much like we did on the left connection port, for the right connection port, we'll change our signal names to out plus and out minus to make our model more intuitive. We can now click the OK button in the MCP Header Editor, and we see that our MCP information has been added to the SPICE wrapper for our S parameter model. When we click the OK button in the Property form, we can zoom in on the canvas and see that the red X that was on our S parameter model has been removed because we now have a model assigned to our S parameter block. To connect our new model to our channel, we can right mouse button on our S parameter block and add a connection to the existing portion of our channel. As we can see in our property form, because we named our nets nicely, the left connection port of our S parameter block has been automatically connected to the positive, negative, and ground of the existing channel. We can now connect our S parameter block to our receiver. Similarly, we can see that the nodes of our block have again been auto-connected to the rest of the channel. And we can pick the OK button in the property form. Our new model, which is an S parameter model captured from a network analyzer, is now connected in our channel, and we can simply select the Start Channel Simulation button to run our channel simulation using our new model. After the simulation is complete, we can view the simulation of our channel, which now includes an S-parameter model that we captured from our network analyzer.